Pulley problems can look difficult at first glance. In this video, we're going to learn how to take this complicated looking problem and turn it into something simpler. Something like this. If this video helps you out, please subscribe or refer a classmate. Let's get on with the problem. If we draw the individual free body diagrams, we quickly see that both have a force of tension. Since they are attached by the same rope, the tensions will be the same. I've drawn this in purple so you can better visualize it. Now we have some good news and some bad news. The bad news is that we don't know the force of tension, and without it, we can't directly solve for acceleration. The good news, however, is that we can make this problem much simpler to solve. All the rope in this problem was actually doing was changing the direction of the force of gravity from box B. In other words, the weight from box B was being redirected by the rope to move box A along the surface. So let's just forget about tension for now and instead create a different but equivalent problem that focuses on the forces that are actually doing the moving. Now this is very important. Just because the rope redirects the weight of B does not mean that the weight and tension are equal. In fact, if the boxes are accelerating, which they are in this case, they will not be equal. So let's not make that assumption. Okay, so now we see that the force of gravity from box B is what is providing the force to move box A. Cool. Now that we see this, we can forget all about the entire pulley system and just pretend that the box is being pushed with that same 19.6 newtons of force. Congratulations! We've converted a complicated dynamics problem to a very basic one. Reward yourself by drawing a new free body diagram. You might find it beneficial to include the values for your variables in the free body diagram. It's optional, but I'm going to do it here. The next step is to apply Newton's second law. The net force is equal to the total mass of the system times its acceleration. Since block A is not moving in the y direction, the net force there is going to be 0, and the normal force and the weight of A will be balanced. We don't need this information in this problem, so we're going to move on to finding the net force in the x direction. Now, since both boxes A and B have mass, they have inertia that will affect the acceleration of the system. Newton's second law requires us to take the total mass of the system into the equation. The next step is to find the net force. Since we don't have any friction or other forces, the only force we need to include is that 19.6 newtons, or the force of gravity from mass B. If this problem had included friction, we would need to include it and subtract it here. Lucky for us, we don't. And that's pretty much it. Now we just need to solve for acceleration, put the numbers into our calculator, and voila! Now, give this problem a try again on your own, except this time, solve it for when box A has a 5 Newton force of friction acting against it. Let me know how it goes. I'll see you later.